Linear infrastructure, which is a necessity in our world, has far-reaching adverse impacts on nature. However, if linear infrastructure planners work with biologists and natural resource managers and project financiers, these adverse impacts can be mitigated. The key is to approach the problem at a landscape level to ensure free movement of animals. Linear infrastructure development should follow a mitigation hierarchy. While it is ideal to completely avoid vital ecosystems of high biodiversity values, when unavoidable, mitigation measures should be included at the concept and design stage of the linear infrastructure. Mitigation measures fall broadly into two categories: engineering structural options and non-structural options. Non-structural options are largely aimed at altering human behavior. These could include speed limits on roads and trains passing through the forest corridor, temporary closures, signs to alert drivers to sites of animal crossings, control on feeding animals on highways, restrictions on traffic movement in linear infrastructure passing through forest areas. Animal detection and warning systems have been used on railway tracks in India. Though manually patrolled, rapidly evolving technology and animal detection systems could be used effectively to affect driver behavior. Other measures, which include structural measures, are designed to alter animal responses. For example, erection of animal-proof fencing, clearing vegetation near road and railway tracks to enhance visibility of animals, retrofitting existing drainage culverts to aid animal crossings. Structural options for roads and railway infrastructure are primarily about maintaining connectivity between the habitats, the linear infrastructure fragments. These include overpasses, underpasses, canopy bridge, box and pipe culverts, fish passages. For effectiveness of structural options, an understanding of animal ecology and behavior is vital. Mitigating measures need to be incorporated for all the possible different animals likely to be impacted by the linear infrastructure. Here are some important considerations while designing mitigating structures. Underpasses. Body size of animal and behavior: solitary, group living, diurnal or nocturnal. In general, the bigger, the better. Height at least equal to width. Openings allow for unobstructed view of habitat across the structure. Location of underpass, overpass based on animal pathways, based on studies, historical routes, landscape features, habitat maps. Overpasses. Width should exceed 30 meters. No steep incline to the overpass unless topography allows it. For arboreal animals, canopy bridges over tracks or roads are ideal. This could be a natural canopy of native trees used by the animals, or like this one for lion-tailed macaques in southern India. Railway tracks present a different challenge for animals like elephants. Ballast on railway tracks serves as a natural impediment to elephant movement. Technical challenges of lifting up railway tracks make engineering options limited or non-existent. In light of this, a new concept has arisen: level crossings for elephants, which enable them to move away quickly from the track in case of an incoming train. Mitigating measures for amphibians, reptiles is even more challenging. Natural habitat culverts, guiding fences, and trying thermoregulatory sites within the habitat could be some options. Reptiles, being cold-blooded, get attracted to warmer road surfaces, and these sites could give them an attractive alternative. Design considerations should also include sound barriers to prevent disturbance to animals, creating funnels to direct animal movement to crossing structures, and integrating them with the habitat through planting native vegetation. Within a landscape, the type of structures and their density should be based on good science about terrain, habitat, animal populations, movement, and behavior. Longer corridors needed more underpasses or overpasses. Power lines, which are a barrier for birds, need mitigation as well. While undergrounding transmission lines is possible, it's costly. When that is not possible, bird diverters or marker devices provide greater visibility to the birds and can avert collisions. Perch deterrents help reduce bird and raptor electrocution by keeping them at bay from high-voltage power lines. The goal with mitigating impacts of linear infrastructure is to ensure landscape-level connectivity to reduce as many impacts as possible for maximum number of species in that habitat and biodiversity values of the landscape. And following the principles of mitigation hierarchy, taking into account design at planning stage and with planners and biologists working together, this is achievable. What is the basic mitigation hierarchy to mitigate impacts of linear infrastructure? Who or what are the non-structural mitigation options aimed at? What are some of the considerations to be taken into account while designing overpasses and underpasses?